Okay, hello and welcome to the exercise walkthrough for week 5. So today I'm going to be talking about lists, which is an interesting and, in my opinion, quite fun subject in Python. So just some practical information, namely that I think it's super important that you try to solve the exercises yourself, and if you feel they are a little difficult or you feel stuck, I would actually recommend that you first go and look at the lectures and read the book and maybe give it a second shot and only use these exercise videos as your last way out. In my opinion, you simply don't learn that much by passively watching videos. But I still included them because, of course, I think if you're really stuck, watching somebody try to think their way through the problem has a value, and that's also why I emphasize quite a lot on how to think about focusing the how to think about solving the problems and practically approach them. So I'm going to focus quite a lot on how to use Visual Studio Code to the best effect, and that's going to be with an eye towards the people who are maybe a little less confident in Python at this point. If you have any comments or suggestions on what I could do better, please let me know on Discord, and you can find the link here. Okay, so without further ado, let's look at the first exercise for today, 5.1. So in this case, we have a lot of different operations on lists that we need to try out and see where it lands us. So the first one is to create a list of numbers and print it out. So I start with Visual Studio Code as usual. Then I go to the terminal. If you don't see the terminal, you can create a terminal using a new terminal here. Sorry, let me just check if I'm recording. Yeah, I am. That was a problem before, namely. Anyway, here's the terminal. Then you type Python to start the Python interpreter, and you can also type Python 3, or if you're on a Mac, for the same effect. And now I have started Python. So lists. We create a list by using the square bracket. So in this case, I want to create a list of numbers. So I can do it like this by inputting the 3 numbers that I want to have in the list, separating them by commas, and remembering to close the list with another square bracket. So that gives me a list with 3 elements. Then if I want to print it out, I can print it out using the print command, and in this case Python will do its best to format it in a nice way. And I can of course include other things in the print command, like a little message such as your list is this. Okay, so that's how I can create a list. Let's look at how we can reverse a list, because that is the second problem. And this is actually a little bit harder, and I'm going to show one approach using slicing. You can also solve this using a for loop, and there are also other constructions that could potentially work. But I think slicing is actually the approach which is maybe most natural, given that this is the startup exercise, like just in the beginning of this exercise sheet. Okay, so how would we approach this problem using slicing? So I think actually I want to approach it using things we saw last week. So let me create a string here called Walkman, because something that we looked at last week was how we could perform operations on strings, and strings have, as it will turn out, will share a lot of similarities with lists, in that a string can be thought of as a sequence of letters, and a list can be thought of as a sequence of elements. So I'm going to talk a little bit about strings first, and then I'll turn back to how we can reverse a list in a moment. Now there are 2 things we can do in order to get elements out of a string. One is direct indexing like this. So this gives me the element number at the 5th place, because we index by 0, 1, 2, 3, 4, 5, m, and that's this m. And then we can also use the slice operator to get perhaps the last elements in the list, starting at 4. That would be man. And we can also slice the other way in order to get the beginning. So in that case, it would give us walk. Now here's a little bit of an observation. When I slice up until 4, I don't include the M in this case. Whereas if I start at the 4, the M is included. And that's just a convention in Python. Okay, so that doesn't sound like I'm reversing a list very much. But what happens if I include, let me start by just including the 0 just for time's sake. I can actually do this, and this is shown in one of the exercises for last week. What this will do is that I'll still start at 0. I'm still going to end at letter 4, but now this last input argument to this last input to the slice will tell me how many steps I take in each turn. So in this case, I take 2 steps. That is, I start at W, and then I count 2 steps forward, 1, 2, and then I get the L, and then 1, 2, and then the string has ended. So if I do this, I get the VL, this and this. And if I took steps of 3, I would get VA, VK, because 0, 3 steps forward, 1, 2, 3, and then K, and that gives me this K. Well, let's try to go all to the end of Walkman, and then we get the last N as well. Okay. So how can I use this? Well, first off, I can think about slicing as like this last input argument counts how many steps I take forward. So what if this input argument was negative? In that case, I would like go in the other direction. And going in the other direction, it really sounds like what we want to do. But then in that case, we don't want to start at index 0. We want to start at index 7. And then we want to end at the beginning of the string, that is at index 0. So logically, like with the right kind of logic at the very least, I can actually start at 7, then I can count towards 0, and then I can take steps of -1. And this is almost going to work. It's going to output this. And now it's a little bit difficult, but if you can see, we're missing the W. But otherwise, it's doing the right thing. We start at element number 7, that's the N. Then we take jumps of -1 each step, so -1, -1, -1. And then we end at 0, but 0 is not going to be included. And remember, 0 wasn't included in when we did slicing like this. It wasn't like this element that we ended up would not be included. That was the M in our previous example. So it's actually kind of logical that 0 is not included, like the W is not included, namely the 0th element. But if I just drop this element here, W is going to be included. So what happens here? I mean, I know it's a little bit tricky, but what happens is actually the equivalent of this syntax, where I just like take a slice of S starting at element 5 and then forward until the end. This will actually start at the last element of Walkman, that is the N, slice towards the end of the word. The end of the word would then be here in steps of -1. And this is why I shouldn't do this, but I should do this in order to reverse the word Walkman in a single call. Okay, so back to lists, because how does this actually relate to lists? It turns out that there is a big connection between list and strings. So if I have a definer list, and let me make a slightly longer list, and I don't want to just put them all in sequence like this, I can do pretty much the same things that I did before. I can ask what's on element number 3. That would be 6, because 0, 1, 2, 3, 6. What's on element 1? That would be 0, 1. First element, that would be 0. I can also slice the list. So I can start at element 1 and slice until the end, and that gives me this sublist. And I can start at element number, like the fourth element in this case, 1, 2, 3, 4, because remember we are zero indexing, and then slice until the end, and that would be this syntax. And therefore I can kind of reuse the same trick. I can start at the end of the list 1, 2, 3, 4, 5, 6, so that would be 7, and then do this, and that will actually reverse this list. It's a little bit tricky, but this is one way of doing it that builds on just using the basic operations and not trying to get into loops right at the beginning. Now there is a ever so slight problem, namely that in this case I need to specify how long the list is. But similar to how you can use the length operation, Walkman, I guess that's the plural, you can use length on a list to get the number of elements. So this would be 3, and therefore this would actually be a way of reversing A regardless of what A is. So enlightened that this is actually how we can reverse a list. Let's move on to the next problem, because now we need to sort the list. This is a problem where we simply need to know something from the book. So think Python tells us that we have a sort function, and I'm not going to, let's actually try to sort this list and print it out, and it doesn't change anything because it's already sorted. But if I defined a new list like this, and then did a.sort, now the list would be sorted in the right order. So this is how we can sort any list. As it turns out, this actually also works if they are strings, because we can compare strings lexicographically in Python. So if I have banana, Walkman, Adam, and I sort it, they are now in lexicographical order. Okay, add a number to the list. So this is a case where I'm thinking about a list of numbers. So by saying add, I think what is meant is really append a number to the end of a list. So if I have a list A of numbers 1, 2, and 9, and then I want to add, let's say, 100 at the end, what I could do is that I can just say 1, 2, and 9 plus 100. This is creating a list of a single element, and then I'm concatenating two lists in this case. So for instance, if I did this, I would get this list out. Okay, here's a slightly tricky thing. What is the empty list? So in Python we can write the empty list like this. So we can just confirm that this list indeed contains 0 elements. So just for fun, what happens if we do this? Well, we just get the list out itself. We don't add it doesn't change the list to concatenate it with an empty list. And this is also true if we do it in the reverse order, like so. Okay, so a lot of basic, I know that I'm describing a lot of operations here for lists, but there are not that many more operations than what I've shown here. Remove a number from the list. Try the last number, the first number, and a number in the middle. There are a couple of different ways we can do this. I think I'm going to use slicing because we already started on slicing. So now to keep things simple, I'm going to define the list as 1, 2, 3, 4, 5, 6, 7, like this, because it makes it easy to see when one has been removed. So if I want to remove the first number, I could just use a slice operation that starts at element 1 and ends at the last element. So in that case, I would just select this sublist. And we can see that this will create a new list with one element removed. What if I wanted to remove the last element? Well, I could just slice until like I end here and don't get this included. Of course, now I need to specify exactly where I want to end, so I need to sort of know that it was supposed to be 6 in this case. Well, what I can do is that I can use the length operation and then just remember to subtract 1 in order to get to the 6. So if I just remember from what I said before with slicing, that if I did this, I would get the full list, whereas if I do this, I end before 7. So that would be one way of doing this. A number in the middle. So I guess when it says a number in the middle, it doesn't have to be a number exactly in the middle of the list. And that simplifies my life a little. Okay, so how can I do this? Well, maybe what I can do, like let's say that I want to remove this. Maybe what I can do is first create this list, then create this list, and then concatenate them together, and then the new list will not contain 4. And of course I'm going to do that with slicing as well. So let's slice up until, oops, that was one too many, up until 3, and then we concatenate that with a case where we start at 4 and then goes towards the end, and that gives me the right new list. So it's maybe convenient to just know that if I do this, I actually get the full list. So the slice operation, there's like a nice symmetry in how the slice operation is defined. But the solution to this problem could be this, where in this case I'm plugging out a number near the middle. Okay. Create a list of strings and print it. Okay, so this is a little simpler than what we've seen before, because I can create a list with anything in it. So like before I create a list of numbers, but I can also create a list of strings like Bob, Alice, Richard. Oops. So this was a typo from my sake. From my point of view, I opened with a double quote and I ended with a single quote, and that's wrong. So now I have a list of strings, and then I can print it out using the print command again. So maybe I can say I don't know, names of 3 people. It's late and I'm not very creative. So this is, I guess, how I could print them out. Only keep the first 3 elements of the list. 3 elements. So now it needs to be a little longer. I think we are going back to integers in this case. So let me create a list of integers and let's make a really nice long list like this. First 3 elements, like, okay, so what was I supposed to do with the first 3 elements? I think I was supposed to keep them. Okay. So of course, what I can do is I can slice starting at the start and ending here. So I guess it's like slice up until 4. No, it's 1 too many. Like this, of course. Yeah, the first 3 elements. Yeah. As you can tell, whenever you're doing something that involves slicing, you're very likely to get off by 1 errors, because you'll make mistakes like this, as I did now. So whenever I have to do operations like this, I always really like to check what the output is and just confirm that it matches my expectation in a simple case. Okay, so that was a bit of slicing. Assign a new value to the second element of the list. This is a good one, because now we're learning how to do something really new. So what I could do, like, let's take this list A again, right? So it's just the numbers. The second element I would get like this because it's 0 index. So this is element 0, this is the element 1, that is the second element. So that gives me 2. But what I can actually do is that I can say 2 is equal to 117. And this is where it's a little bit tricky, because you could potentially think that this would update the value of 2, like the number 2, and it doesn't. What it actually does is that it takes 117 and then it plugs it in onto this slot in the list. So it doesn't print out anything, but now A is updated, so it has a new value here. So if I wanted to update this one, I would first need to figure out how to get it, and maybe I could do that using the length operation, and that would give me the last element. Sorry. And then I could say that now it should be equal to, let's say it's 100, it's 1000 for instance, and now I have updated the last element of the list. There's a simpler shorthand here, because remember that lists have the property that I can get the last element using -1, and that means that I could actually update the last element like this if I wanted to. Okay, I'm getting a little bit sidetracked. Try out what happens when you assign the same list to 2 different variables and then modify one of the variables. Why is it important to keep that in mind? Okay, so what are we supposed to do here? We are supposed to define a list like this. So let's say we have a list 1, 2, 3. And then I assign it to a second variable, and I call that B. So now A is equal to this, and B is equal to this. So let's try to modify one of the list, and it'll turn out that it doesn't matter which one I select. So let me try to take A, and then let me try to put something into the first place in A. So let's say that should be equal to 10. So before it was 1, and now it will be 10. So it looks like this. What has happened to B? Well, this is where it gets super tricky, because B has also been updated. So the problem is that I defined A up here, and then I defined B to be equal to A. And then when I change this list A, I'm actually, like, A only exists in one place in Python, so B is just pointing towards A. And that means that when I print out B, I get the same list back. And that is why when I change one, I also change the other one. We can just test it by modifying B like this and say that should be equal to -100. Now B is updated as we expect, but A will also be updated. There's only a single list in this case. So maybe that can be a little bit dangerous, because if you have multiple functions, it's very easy to actually end up with duplicated, like, list where it looks like they're different. Like, if I look at this code, I think A and B are 2 different lists, but they're actually the same. And then you have a function that updates the list in A, and then it'll affect the list in variable B, which is in a different place in your program, and that can create a lot of confusion. So how would I avoid that? Well, I could actually avoid it by just, like, defining A as I did before, and then defining B as 1, 2, 3. And now they point to 2 different lists. So if I take A and update it, I don't have this problem anymore. And B, like, let's say we take element, the second element, say it's 100, B is updated, A is not updated. So this will be how you should avoid the problem. So be a little bit careful about this. It's the first place where we see this kind of problem crop up, and it's just generally something to be watchful for. I've spent hours on problems that actually derive from this kind of problem, like this, or property, I should probably say, in Python. Sometimes it's desirable. Like sometimes you actually, like there's a reason why Python doesn't just create a new like why when I do, when I do this in Python, there's a reason why A and B are the same here. There's also situations where it can be convenient, but there's certainly also situations where it can be very confusing. Okay, so be on the lookout for that, and I think I'll end this video here.